Myself R.M. Harish Pawan. Today I am going to explain about ACID properties in NoSQL. Let us explore the application of ACID properties in NoSQL database, a topic of growing importance for developers working with large scale distributed data. What is ACID? A stands for atomicity, C stands for consistency, I for isolation, D for durability. In atomicity, all operations within a transaction succeed or fail as a single unit. Transaction ensures data remains consistent and valid according to the predefined rules. In isolation, multiple transactions occurs independently, preventing interference with one another. Durability. Committed transactions are permanently stored, even the face of the system failures. Challenge Challenges of ACID in NoSQL. Scalability, performance, and flexibility are the challenges, which scalability ACID guarantees can be challenging to maintain with the distributed nature of NoSQL database. Performance. Ensuring ACID compliance can impact performance, especially in high volume real time scenarios. Flexibility. ACID principle can sometimes limit flexibility and database designed for rapid data changes. Atomicity in NoSQL. Partial success and rollback strategies. A NoSQL database may allow partial success. NoSQL database may allow partial success where some operations within a transaction complete while other fail. Consistency in NoSQL. Eventually, consistency data reaches consistent state across the system through there might be a delay. Strong consistency. Data remains consistent immediately across all nodes but cannot be challenging to implement. Conditional updates are using conditional statements. Updates can be applied only if certain conditions are met, ensuring data integrity. Isolation in NoSQL. Read committed, snapshot isolation, serializable isolation. Transaction read only committed data but may see uncommitted changes from other transactions. Snapshot isolation are which each transaction operates on consistent snapshot data minimizing interfaces. Serializable isolation transaction behave as if they executed sequentially providing highest level of isolation. Durability in NoSQL. Replication data is replaced across multiple nodes, increasing resilience to the failures. Write ahead log transaction changes are returned to log before the being applied to the main data store. Commit logs are used to track changes and allow case of trade-offs of acid versus basis. Acid is strong consistency complex transactions potentially slower performance. Second in base eventually consistent simpler transaction potential higher performance. Choices depends on application requirement, data consistency and performance execution. Techniques for acid-like properties in NoSQL. First technique is optimistic locking. Minimize data contamination by assuming updates are infrequent, validating before applying. The second point of acid-like properties in NoSQL is conflict resolution. Mechanism to resolve conflicts arising from the current updates, ensuring consistency. The techniques like the third techniques are distributed conscious techniques like Paxos or Raft ensure agreement among the nodes. Thank you.